Hello, good evening. So today we will discuss from the first chapter. Discuss from the first chapter of A.C. VERMA, Introduction to Physics, which generally talks about the dimension analysis part. And today we are going to discuss about problem 10 to problem number 17. So first come to problem number 10. It says the height of mercury column in a barometer in a Calcutta laboratory was recorded to be 75 centimeter. Calculate this pressure in SI and CGS units. And the given data are specific gravity of mercury is equal to 13.6, density of water is equal to 10 cube kg per meter cube, G is equal to 9.8 per meter per second square at Calcutta. And the formula for pressure is H rho G, where H is height, rho is density of the corresponding mercury column here, and G is acceleration due to gravity. Now density of Hg is equal to, Hg means mercury, is equal to density of water into specific gravity of mercury, and the unit will be in SI. Now given the height H is equal to 75 centimeter or 0.75 meter, density of mercury is 13.6 into 10 cube kg per meter cube from this formula is equal to 13,600 kg per meter cube, which is rho basically, and in CGS it is 13.6 gram per semi cube, and G is equal to 9.8 meter per second square. Therefore pressure is equal to H rho G is equal to putting the values of H, rho and G, we get almost the answer which is in SI unit, which is almost equal to 10 into 10 to the power 4 Newton per meter square. And in CGS, P is equal to H rho G, and converting Newton to dyne and meter square to centimeter square, we get 10 into 10 to the power 5 dyne per semi square. Now let's discuss the problem number 11. Express the power of 100 watt bulb in CGS unit. So in SI, 1 watt means 1 joule per second. Therefore 100 watt is equal to 100 joule per second. Now for CGS, we have to convert the joule to arc. So 1 joule, we know 1 joule is equal to 10 to the power 7 arc. Therefore 100 joule is equal to 10 to the power 9 arc, that is 10 to the power 7 into 100 arc. Therefore in CGS unit the power is 10 to the power 9 arc per second, that is rate of change of work, that is work done per unit time. Now let's go to problem number 12. The normal duration of ISC physics practical period in Indian colleges is 100 minutes. Express this period in microcenturies. Given 1 microcentury is equal to 10 to the power minus 6 into 100 years, that is 10 to the power minus 4 years. And there is a separate question: how many microcenturies did you sleep yesterday? Now 1 year is equal to 365 days. We know each day is 24 hours, so it is 365 days is equal to 365 into 24 hours, and each hour is 60 minutes. So we can write it as 365 into 24 into 60 minutes, which is equal to 5600 minutes. Now this minutes is equal to 1 year. Therefore 100 minutes we calculate is equal to 1 over 5256 year. And now converting from year to microcenturies, we get 100 minutes is equal to 1 by 5256 years is equal to 1 over 5256 whole into 10 to the power 4 microcenturies. After calculation we get it approximately 1.9026 microcenturies. It is the answer. And about the sleeping part, for me Yesterday I slept 7 years roughly. So 7 years is equal to 420 minutes. Now 100 minutes is equal to 1.9026 microcenturies. From here we get that. Therefore, using unitary methods, we derive 420 minutes is equal to 7.99092 microcenturies, which is approximately 8 microcenturies. That is the sleeping time of me yesterday. Now, looking forward to problem number 13 and its solution. The surface tension of water is 72 dyne per semi. Convert it in SI unit. Now, first we calculate 1 dyne. First, we learn to calculate 1 dyne is equal to, what is meant by 1 dyne is equal to 1 gram semi per second square. Since F is equal to ma, m is mass, a is acceleration, and F is force. And in CGS unit, m mass, its dimension would be gram, and acceleration's dimension unit would be gram, and acceleration's unit would be semi per second square. So after calculating, we get it to be 10 to the power minus 5 kg meter per second square, and this kg meter per second square is called Newton. So 1 dyne is equal to 10 to the power minus 5 Newton. Now in SI units, 72 dyne per semi is equal to 72 dyne per 1 semi. We can write that is equal to 72 into 10 to the power 5, 10 to the power minus 5 Newton, which we get from here, and 1 semi is equal to 10 to the power minus 2 meter. We know that, and after calculating, we get in the surface tension in SI unit as 0.072 Newton per meter. It is a final answer. Now we go to problem number 14. It says the kinetic energy K of a rotating body depends on its moment of inertia I and its angular speed omega. Assuming the relation to be K is equal to kappa into I to the power A omega to the power B, where kappa is a dimensionless constant. So its dimension is basically m to the power 0, L to the power 0, that is equal to 1. No dimension is attached to kappa. And we have to derive A and B. And given moment of inertia of a sphere is about its diameter is 2 by 5 mr square. 2 by 5 is a number, so the dimension of mr square would be the dimension of moment of inertia. Now we write down the formula. K is equal to kappa I to the power A omega to the power B. Now dimension of left hand side is equal to ml2 t to the power minus 2, since it is kinetic energy, and energy's dimension is ml2 t to the power minus 2. Now dimension of RHS is equal to, for kappa it is 1 into ml square whole to the power A t to the, and for omega it is t to the power minus 1 to the power B, which is equal to m to the power A L to the power 2A t to the power minus B. Now we are comparing for LHS and RHS using the homogeneity principle of dimension. So we get m here, the power of m is 1, here it is A. So 1 is equal to A, this is number 1, L square, and here it is L to the power 2A. So 2 is equal to 2A, again it is 1 is equal to A, and here left hand side it is t to the power minus 2, and right hand side here it is t to the power minus B. So minus 2 is equal to minus B. From here we get B is equal to 2. So our final answer is A is equal to 1 and B is equal to 2. Now let's move on to problem number 15. It says theory of relativity reveals that mass can be converted into energy. The energy E so obtained is proportional to certain powers of mass m and the speed c of light. Now we have to guess the relation among the quantities using the method of dimensions. So given E proportional to m to the power something A and c to the power something B. where m is mass and c is speed of light. E is the corresponding energy. So when we write is equal to sign in place of proportion, we have a proportionality constant k. It is the k is a proportionality constant. So therefore E is equal to k m to the power a c to the power b. Now dimension for LHS, it is energy, so E is equal to ml2 t to the power minus 2, and for RHS it is m to the power a into L t to the power minus 1 whole to the power b, and rearranging we get m to the power a, L to the power b, t to the power minus b. Now we have to compare these two, LHS and RHS. Now according to principle of homogeneity of dimension, ml2 t to the power minus 2 is equal to m to the power a, L to the power b, t to the power minus b. Comparing both sides we get 1 is equal to a, here 1 is equal to a, 2 is equal to b, and minus 2 is equal to minus b, which is again b is equal to 2. Therefore a is equal to 1 and b is equal to 2. Therefore the relation is E is equal to k m to the power 1 c to the power 2. The relation is E is equal to k m to the power 1 c to the power 2, that is E is equal to k into mc square. Now question number 16, that I is equal to current through a conductor, R its resistance, and V is the potential difference across its ends. According to Ohm's law, product of two of these quantities equals the third. Obtain Ohm's law from dimensional analysis, which we have already learned. And given dimensional formula for R and V are ml2 I to the power minus 2 t to the power minus 3. It is for R, and for V it is ml2 t to the power minus 3 I to the power minus 1 respectively. Now we go to its solution. First we see that the given dimensional formula for V is ml2 t to the power minus 3 I to the power minus 1. We have also calculated it here, but there is no need since it is given. And also given is a dimensional formula for R, which is ml2 t to the power minus 3 I to the power minus 2, which I, for convenience, I have written I to the power minus 1 into I to the power minus 1. And since I is a base quantity or fundamental quantity, we can write the dimensional formula for I is equal to I. Therefore, from V we can write V's dimensional formula m is equal ml2 t to the power minus 3 I to the power minus 1. It can be written as ml2 t to the power minus 3 I to the power minus 1 into I to the power minus 1 into I to the power plus 1. That I to the power plus 1 or I we have written separately. Now this is the dimension of I, this is the dimension of R, and this is the dimension of V. Therefore V is equal to Ri, and therefore we have got the Ohm's law. We have got the Ohm's law, which is V is equal to IR. Now finally we move on to today's last problem and solve this. The frequency of vibration f of a string depends on the length L between the nodes, the tension F in the string, and its mass per unit length small m. Gives the expression for its frequency from dimensional analysis. So we directly write F is equal to K, where K is the dimensionless proportionality constant, L to the power alpha, F to the power some beta, and M to the power some gamma. And we know dimension of F is t to the power minus 1, since it is the inverse of frequency. And we have to write down the dimension of RHS, that is right hand side. L to the power alpha for length, F's dimensional formula is ml t to the power minus 2, and F to the power b is therefore ml to the t to the power minus 2 whole to the power beta. and small m is the mass per unit length, that is small m is equal to capital M by L, and we put it here and we get into m over L whole to the power gamma, and rearranging it we get m to the power beta plus gamma, L to the power alpha plus beta minus gamma, and T to the power minus 2 beta. And comparing LHS and RHS, we get 0 is equal to beta plus gamma. From here we can write gamma is equal to minus beta. It is marked as 1, and here m and L has the power 0. Therefore, it is for the calculation of the power of m, and it is for the calculation of power L, which is also 0, right? Because t to the power minus 1 we can write it as t to the power minus 1 we can write it as m to the power 0, L to the power 0, t to the power minus 1, isn't it? So we for comparing the powers of L from both sides, we get 0 is equal to alpha plus beta minus gamma. From here we get 0 is equal to alpha plus beta minus, in place of gamma we place minus beta, applying 1, and from there we get alpha plus 2 beta is equal to 0. We marked it as 2, and from the dimensional formula's power of T, we get minus 1 is equal to minus 2 beta. Therefore, beta is equal to half. And since beta is equal to half and gamma is equal to minus beta, we can write gamma is equal to minus half, and from 2 we get alpha is equal to minus 2 beta. Therefore, alpha is equal to minus 2 into half is equal to minus 1. Therefore, we can write the formula of frequency f is equal to k into L to the power minus 1, f to the power half, m to the power minus half. Now, f to the power half means root half, and m to the power minus half means 1 by m to the power half, which is 1 by root m. So putting these, we get f is equal to k into 1 by L, since it is L to the power minus 1, 1 by L into root over f into 1 over root over m. So finally we get the expression, we can guess the expression of f as something k, some constant k, into 1 over L into root over f over small m. It is the answer for this question. And that's it for today. If you have any doubt or queries about this section, feel free to comment below. And if you like this video and the AC VERMA series, kindly give it a thumbs up, and don't forget to like, share to your friends, and subscribe to this channel to get such more videos. Thank you.